All right. So as I said in the presentation, guys, that engineering is about as far away from what I thought I'd end up doing with my life as you could possibly imagine. Throughout high school, I was very interested in sports, and I was one of those strange guys that actually sort of enjoyed school. So I thought I'd be a teacher and a coach, and that's basically I applied to Edinboro, got accepted, went up there, and uh, I met my wife in probably 2 weeks into my second year, and we sort of knew fairly quickly. I mean, we got engaged 3-4 months later, um, and she very quickly changed my direction from physical education to, and she didn't specifically say engineering. Really, all she said was uh, that physical education teachers, the jobs they're not really out there, and even if you get one, you're really not going to make any money. So she convinced me to look into something different. And as I mentioned in my presentation, a good friend of mine was an engineering student at Pitt, so I spoke to him, and after discussing it with him, I thought it might be a nice avenue. And to be quite honest, I didn't even know what engineers really did at that juncture. So so I applied to Pitt, and amazingly, I was accepted, and started there in the fall of '79. And I basically had to start back over again because, as you can imagine, phys ed doesn't really translate very well to engineering. And so I went from 78 credits all the way back down to 10, started back over. And I worked, I basically, I went to school at night. I went to school full time for a year and worked at night. It worked out well because I worked as a security guard at a manufacturing center. So there really wasn't a lot of true work to be done. I just had to be there so I could study all night, which was helpful. Did that for a year, and then came to the realization that if my wife got pregnant, she was the only one really bringing in any money of consequence at the time, that we were really going to be in deep trouble. So I started looking around for a job and applied at Westinghouse Nuclear, and had 4 interviews, got offered all 4 positions. Took one of those in thermal hydraulics group and started working there in June of 1980. I went to night classes, and it took me about 6 more years to finish up and get my bachelor's in mechanical engineering. I looked into, and I think as we get into this presentation further, you guys have already seen that I included some information on, what opportunities there are in engineering, what types of engineering, things along those lines. I think that it's worth saying that there are all kinds of different opportunities in engineering, and as we'll say towards the end of the presentation, there are all kinds of opportunities out there. They're always in demand, and I think it's always interesting, and that's one of the things that really drew me to it as well. It wasn't really a passion of mine, never became a passion of mine, I would say, but it was extremely rewarding and gratifying as I went through it. And again, guys, if you have any questions as we go, just chime on in. I don't know how much time we need to spend on this. This just gives you sort of a timeline on where I went and what I did. So as I already mentioned, I received my bachelor's in 1986. I became a research engineer at Carnegie Mellon, because during that 6-year period from 80 to 86, I worked at Westinghouse Nuclear. From 86 to 94, I was a research engineer at Carnegie Mellon. And then from 94 to 2016, I was in various roles at what originally was Westinghouse Transportation, and evolved into a company called Bombardier, heavily involved in transportation again. This goes into a little more detail on the actual professional roles that I performed while I was there. In the thermal hydraulics group, again, the key there was evaluating the core. There's nuclear fuel inside of fuel rods. And I was saying to Ty the other day, and I have sort of a slide. I think the next one is it. Yeah. You guys can see this slide of a nuclear power plant. Okay. It's interesting because, I mean, it's really not that much different than a teapot. You know, you have a teapot with one of those little pinwheels. That's honestly, it's not that much different than that. You know, you basically use the nuclear fuel to heat up water, and actually they keep the water in the vessel different than the secondary system. So basically, they just run the water in the secondary system next to the water coming out of the primary system, so you get the heat transfer. That turns it into steam, and then it powers the generator, if you will. So anyways, my role was to evaluate the core to make sure that the fuel is not overheating. Probably our single biggest responsibility was making sure that it never melted down. So not a small thing. You know, we ran all kinds of computer simulations just to make sure that as the water went through, it never did what's called nucleic boiling. You never wanted it to go. If you ever formed any kind of small air bubbles on the outside of the fuel rods, those became like insulation, and the heat just went through the roof in no time at all. So the simulations that we did just had to make sure that that never occurred. Let me see.
Were you doing that while you were in high school? Like you were doing that while you were still in high school?
No, while I was taking my engineering
college,
degree.
yeah.
Yes,
Yeah,
you're right,
yeah. Well,
Nate.
you were taking your career.
That's right. So basically, in the thermohydraulic department, there were a myriad of engineers, true engineers. And as a technician, I would run simulations. And actually, as I became more and more experienced, I had more and more, you know, advanced roles and responsibilities. But anytime I did something, the lead engineer on the project had to check it to make sure that it was correct, and he had to sign off on it, which you can understand. I mean, when you're talking about something as critical as that, you don't want a guy that's still in college, you know, just doing that stuff. So, but it was also nice because I had access to some pretty smart people as I was going through my degree at night. So, you know, I would work 50 hours during the week, and then I'd go to school, you know, and I would typically take 6 to 10 credits every semester for 3 semesters throughout the year. So I only got, for those 6 years, I had 3 2-week breaks. So I had 6 weeks off out of the 52 weeks where I wasn't going to college. And so it was pretty rigorous, but definitely paid off for me. And the great thing was Westinghouse paid for my education. So as I got my degree, yeah, I seen Jack's like, whoa, what's that? You say they're paying for it? Yes, guys, there are places out there that will pay for your education. Now, one of the prerequisites for Westinghouse was you already had to have like 60 credits. And the irony was most of my credits were in physical education, but somehow that didn't seem to matter to them, which surprised me. But yeah, they paid for my education. All you had to do was get, I think it was a B or better in your classes, something like that. If you get a B or better, then they will compensate you for all your tuition. So, you know, obviously I was living at home anyway, so I didn't have actual room and board per se. So that was very beneficial. Let's go back to the prior slide. If I can get my mouse to come back to me. There it is. Where are you again? Come on, guys. Let me go to this. There we go. Oh, we go. Okay. We do this and previous. There you go. So, okay. So that was Westinghouse Nuclear, Carnegie Mellon. I worked there as a research engineer, and we had 2 particular jobs that we did. We had a lot of research that we did in, I was the lead engineer on the maglev project that was run out of Pittsburgh. And we tried to solicit funding and win the award, if you will, from the federal government, which actually never got awarded to anybody. But we worked closely with a whole host of entities, including Duquesne Light, Carnegie Mellon University, Westinghouse Transportation, Michael Baker Engineers, the Urban Redevelopment Authority, so on and so forth. And so I was the lead engineer on that, got a chance to go over and work on the Emsland system in Germany, which was pretty cool, being able to work with the lead engineer there, being trained on the maglev technology, as well as attending a whole bunch of conferences on the subject and even presenting several times. We also did, our mainstay for funding, if you will, was to do energy evaluations of transit authorities. So here in Pittsburgh, we have what's called the Port Authority Transit. Nate and Jack, are you guys both familiar with that? The Port Authority Transit here in Pittsburgh, the T as they call it. Okay, so that was one of the systems, but we've done systems in Australia and all over the world. And simplistically, what we would do is we would get all the information, the alignment of the system, grades it's going up, curves it's going around, the tractive effort speed curves for the trains, the different trains they had, the overall electrical network simulation. And we would run simulations of their transit authorities and be able to tell the transit authority exactly how much energy that they were using. We would also get information from their utilities and be able to evaluate against actual operation to verify that our simulations were working. You follow what I'm saying? So there's actuals where they said they ran this train from point A to point B and it had this many people on it and it was going this speed and all that sort of stuff. And then they would say it took this many kilowatt hours of energy. Okay, well, we would run our simulations and say, you know what? We ran our simulations and it matches exactly with what your actuals were. So once you do that on several different alignments, you start to realize that your simulation is working fine. Well, what did that enable us to do? That allowed us to look at all kinds of different operational scenarios to save the transit authority tons of energy. Things like regeneration, where you reverse the motors and send that energy back onto the utility line, thereby reducing your overall energy needs. Coasting, a whole host of different operational strategies that we could do. And typically we would save a transit authority 15 to 20% of their energy bill. Well, if their energy bill is $5 million, then we're saving them $1 million. And it would only cost them like $250,000 one time. So the rate of return on their investment was extremely good. So we did a lot of research, flywheel, maglev, a whole bunch of different stuff like that, as well as sort of the meat and potatoes, which were to do these energy studies for all kinds of transit authorities. Then I took a job at Bombardier. I worked as a systems engineer, and the very first job that I had was the lead engineer on the high-speed train system for Amtrak for the Northeast Corridor, going from Boston to New York. Those trains can go as fast as like 100, I think it's 160 miles an hour or something like that. So I did that as my first job, but I was actually recruited then into sales shortly after I started at Bombardier. Moved to sales and then on to cost engineering manager in 2001 and bid management director in 2008 until I retired in 2016. And one of the neat things that I tried to convey to Ty was how exciting it was for me to get a chance to spend copious amounts of time working closely with people from all over the world. I hired people, as I said in my presentation, from everywhere. I had people working for me from China, from the Philippines, Honduras, Peru, Brazil, you name it, which, I'm trying to remember 50 years ago when I was in high school, I would have never in my wildest dreams imagined that I would have been able to do something like that. And it has been one of the most rewarding aspects of my life, getting a chance to work closely with these people and getting a sense of what these folks from such diverse cultures, what makes them tick, how are they different? How are they the same? What do I like of their culture, if you will? So that's sort of my different roles. I already went through this thing. This is just a nice little map of the Washington Metro system, which is quite complex. And again, this obviously is not to scale, but it gives you a sense of the different lines that they have, which they color code, and the different stations. And we would map all of that into in real time. Exactly what the computer simulation would look at is every alignment. You're going up a grade, you're going around a curve, so on and so forth, and be able to tell them exactly what what their system was using energy wise, which is, again, anytime you're in the public realm, you're under the gun with your budget. So if you can save 20% on your energy bill, that is huge for you as a transit authority. So it was a pretty cool job. At CMU, I was also the lead engineer on the Trans Rapid system. That was pretty exciting. I mean, these trains traveled, 300 miles an hour. So that was a pretty cool experience to be able to do that. I actually went over to Emsland in Germany, as I said, and spent a couple of weeks there working with one of the designers of the system, so that we were totally on board with what they did. And then with Bombardier, these are just examples of the types of systems that I was involved in building. So the entity here in Pittsburgh, its genesis was in building people movers, as you see in the top left picture, like the San Francisco automated people mover there. We also built the system in Newark, and if you mention airports, Orlando, Tampa, Denver, Los Angeles, I mean, you're talking our systems. Dallas, Houston, they're virtually probably in 70-80% of the airports domestically. And then you could talk about international. We've got 3 systems in London. We've got systems in Frankfurt. We've got systems in Shanghai. We've got systems all over the world, if you will.
Hi.
And I'm sorry, somebody was asking a question?
Oh, no, it's my father. I was telling him to be a little quiet because I'm watching the video and you're
That's
talking.
fine, Jack. That's fine, Jack. No problem. So these are just examples of the types of systems that I worked on. And my role, again, it evolved quite quickly from an engineer that actually was involved in the design and application, if you will, of a transit system, actually constructing it, if you will, into an entity. I was then involved in actually selling the transit system. And then I was involved in the financial ends. Actually, I was responsible, my organization was responsible for pricing them. And as I was saying to Ty, some of the projects I was involved in were in the $5 to $10 billion range. So we're talking a lot of money here. We're talking a lot of money. And some of them were a lot less expensive. Like a people mover might be, I don't know, might be 30 to 50 million, something in that range. But if you're looking at a concession project where the transit authority or the actual municipality is awarding a contract, not just for you to design and build the system, but also to operate and maintain it for 30 years, those type of projects can easily run into the billions of dollars. So it would be a very onerous, endeavor, one where we work closely with Nate. I think you said you were looking to become a civil engineer. We would always team with a civil company. We would team with an electrical engineering company. We would team with an operational company. We might team with a financial entity who's figuring out the financial end of things. And then we'd be responsible for providing the trains themselves, the signaling system that make sure the trains operate safely, communication systems, maintenance facility, things along those lines. All right. Now, one of the things in talking to Ty that I thought might be of worth would be for me to at least give you guys a sense, and I'm not sure how much you've been exposed to different types of engineering and what are the opportunities out there. So some of this is stuff that I provided on my own. Some of it I went and tried to dig up background for it, so it was substantiated, if you will. So let's just delve into that. So there's a whole host of different types of engineering that are out there. So I heard you, Jack, that you're interested in aeronautical or aerospace engineering. And Nate, I heard you speak about civil. Where are you guys at? What grade, if you don't mind me asking, what grade are you in?
Sophomore.
And Nate?
I'm a junior.
Have you guys already thought about schools?
Yeah, there's a certain school that I'm looking into from Pittsburgh that actually teaches aerospace that I'm considering. But then yet again, if I need to stay local, I'm considering going to Barron.
Barron's a good school. What's the school in Pittsburgh that's aerospace engineer?
I'm not entirely sure of the name, but I do know that it is out there. I'm trying to look for it because my father had mentioned it to me before from his friend going to that school. So
There's a whole host of schools, you know, Robert Morris, Duquesne, Pitt, Carnegie Mellon, Chatham, Carlow. You know, there's a whole host of universities here in Pittsburgh. Nate, have you looked at a school as well?
Yeah, I mean, going around with my siblings, I've gone to many different colleges. One that looked interesting was a engineering school called Laterno down in Texas that my sister went to. But yeah.
Well, that's cool. All right, so again, I put the link down below. So if you're not already aware of all the different types of engineering, I think that's more exhaustive. You can go there and take a look at that. Again, you know, I've worked with pretty much all these types of engineers, you know, having come through the nuclear and transportation and so on and so forth. I've had a chance to work with just about all these different types of guys. You know, geotechnical. Yeah, Jack.
I do have a question. Have you ever worked with General Electrics or Wabtec in your time?
Yes, I have. As a matter of fact, Wabtec, there's a number of folks that left my company and went to Wabtec. So yes, I have.
I was asking because my father is actually one of the head line leaders at Wabtec, so I was figuring that maybe there was some kind of correlation because most of the reason why I got so closely attached to engineering quickly was because of him, and he kind of showed me basically everything they had to offer there that was available. So
Well, Wabtec is a very good company, and actually, the guy that ran it up until recently is a friend of mine, and he was one of my bosses for a while. A guy named Ray Bettler. So ask your dad if he knows who Ray Bettler is, because and it'd be interesting if you know, because I know a whole host of folks that are fairly high up the food chain at Wabtec. So it'd be sort of interesting if he happens to have, you know, a boss that was a good friend of mine, because there's a bunch of people there that are good friends of mine.
Yeah, that's what I was reading the other day when you mentioned Ray Bettler. I looked him up on my phone, and it was like, oh, he was like, I don't know, president of Wabtec or something for a bit?
Yes,
or?
he was.
Okay.
Just a phenomenal individual,
Yeah.
the type of person that you'd be willing to go to war with. But okay, so you can obviously go to that website. And I thought also, you know, if I'm sitting in you guys' shoes, I may have some curiosity about types of salaries and things like that. So again, I tried to delve into it. I mean, I've hired probably 30 to 40 people, guys. So I have an idea, and all of them were engineers. So I have a decent idea of what a starting salary for various types of engineers are. I would expect in today's world, coming out of college with a decent QPA, you know, in hopefully the 3.3 to 3.5 at least range, you should be making somewhere in the $55,000 to $70,000 range, something like that. Now, keeping in mind that most universities you go to these days are going to be charging you somewhere in the neighborhood of, I would say the University of Pittsburgh right now, you're probably going to drop somewhere around, let me think now, probably around 40,000 a year, 50,000. I'm guessing that Carnegie Mellon, a 4-year degree at Carnegie Mellon is probably going to cost you 400,000. I'm going to guess, if you're not getting any compensation from the university.
And that's the thing, when you guys look to go to universities and stuff, you got to look at the correlation between like what you're going to be going to school for, and how much you're going to make when you get out of school, and is if that salary is going to be, if you're going to be able to get that money back with the salary of how much you're going to spend to school. You know, I'm not going to be going to a school that's going to cost $50,000 a year to be a teacher, for instance. You know, it's just not going to make sense to do that, right? Doesn't that make sense? I mean,
How How fast did you get it up to already?
With that,
He's talking with his dad.
okay, well, yeah. I mean, obviously, I think anytime that you're talking about spending that kind of money, you're going to want to make sure there's going to be a return on your investment. So, consider that. And guys, I was looking at some statistics before I got on this meeting, and one of the things that that it said was that 80% of students change their at least once, and that the average is changing 3 times. So just, again, consider as best you can what you want to be, but don't be surprised like I was going from phys ed to engineering. Actually, I went from phys ed to electrical engineering to mechanical engineering. So I changed twice. But do your homework. How much money you're going to make, what kind of job opportunities are out there. I mean, it's no good. Both of my kids, quite frankly, went into degrees that I wasn't really very happy with. And neither one of them are working in the field. They both have degrees and did well in school, but neither one of them are working in the field that they got degrees in. It's, being altruistic is nice, and following a passion is nice too. It can be very rewarding, but I think it's also important to be realistic. If there's a very limited number of jobs out there for a particular curriculum, you have to question whether that's going to be beneficial. So just think about that as you're doing it. So again, I put this information here and put the link at the bottom to try to give you a sense of what you might get once you get out of college and compensation, if you will. So obviously, engineering is very high up the salary food chain. If you look at different occupations, engineering is always going to be near the top, and you can see the median salary is pretty much around $100,000 for just about all of them. So you can make a living in engineering for sure.
During your career, how much did you make?
I
How
don't
much did
really
I make?
think he's going to talk about his salaries here.
I can. Well, geez, oh man, Nate, that's a loaded one. I can tell you that again, once you get fairly high up the food chain in companies, Nate, you start to get bonuses, and you also see another aspect of working for large companies, because Bombardier had 70,000 employees globally. They have retention incentives. So what they do is they give you stock options, and they say, look, you don't get these unless you're here 3 years from now. So what would happen is, picture right now, Nate, that somebody at General McLean comes to you and says, Nate, you're an important part of this school. We want you to stay here. So here is a check for $5,000. If you're here when you graduate, you get to cash this. If you're not here when you graduate, then you can rip it up. That's what companies do. So they give you bonuses, they give you stock options, and yeah, I can tell you that I made a nice amount of money, a very nice amount of money. So while I didn't get to follow my passion of being a phys ed teacher and a coach, I did provide for my family better than I ever imagined I would. And I paid for my kids' educations. Not a one of them had to pay 1 penny for books, for tuition, for room and board. I paid for every cent. So my children are some of the rare kids that did not have 1 penny of debt when they left school. And the other side of it is, while I'll always wonder, about my passion about having been a coach, maybe rising up to the Mike Krzyzewski level or something like that, being a college coach in some sport. The other side of it is the experiences that I had in engineering. There really is something about building something and seeing it, seeing nothing and then seeing a transit system or seeing a nuclear power plant or whatever it might be. It's about as rewarding as I think as you're ever going to find. And then also having a chance to work with all these people, I've said that several times, from throughout the globe, those experiences, I can't put a price tag on them. It's been phenomenal. And engineering provides you all that. As I say later on, actually, real quickly, I mean, I think you guys saw this, and I imagine most of it's fairly obvious. You know, these types of things are going to be key if you want to be an engineer. You know, you have to have problem solving skills. You know, you need to be a team player. You know, you got to be creative, so on and so forth. But one of the things in my life, and I don't know that it's necessarily critical for every engineer, maybe some folks who are in the 99th percentile intelligence wise don't have to worry about it too much. I think most of us are going to run into a wall somewhere along the way. I don't know, Jack or Nate, if you've experienced that already, where you've taken a subject or had a particular job to do that you literally didn't know exactly how to do it, and or where to go or how to figure it out. And the last one that I put on here, being tenacious, there's something to be said for that, guys. If it's really important, you know, it's really important to strive for success, but man, you need to know how to deal with failure. So being tenacious and never saying die, I think is a very critical attribute of being an engineer. I hired a lot of people, as I mentioned, and you know, what did I look for in a prospective candidate? A lot of them were college graduates. You know, a lot of them were more seasoned, you know, 10 to 20 years, but a lot of them were college graduates. And what did I look for? Again, sort of along the lines of tenacious, I'm looking for somebody who's really highly motivated. I would tell candidates that would come in and interview for my jobs, I would say, guys, look, two things. You're never going to work harder than you're going to work in my department. You're never, ever in your life going to work harder than you do working for me. But the opportunities you're going to get out of this job are going to be absolutely phenomenal, and you will never, ever be bored. So I'm looking for someone who's motivated, highly motivated, someone who's a hard worker, has strong communication skills, likes working in a team. And if it is a new graduate, I mean, obviously, if you're highly motivated, you would expect to get a high QPA. And certainly a diverse background. For myself, I was heavily involved in chess. I don't know if Nate or Jack, either one of you guys play chess.
I used to, but not really anymore.
Nate?
I play it some, yeah.
Well, I was first board on my high school team that actually won Western Pennsylvania. So it was, it's just something that I've always really enjoyed. And as I've become, you know, a manager and hiring people, you know, a manager, a director, so on and so forth, you know, I'm looking for those types of other aspects of you know, what the potential hiree is doing. Engineering pros and cons. Did you guys already read through this, or should I go through it a little bit more?
You can go through it if you'd like.
Yeah.
You've already read it before.
All right. Again, from my perspective, and I don't know what you guys have done in your lives, you know, if you were involved in Cub Scouts or building something or whatever it might be, there's nothing that rivals starting with nothing and finishing with something, you know, whether it be, you know, like in my house, you know, I've basically, I've built a patio and a deck. I've redesigned my kitchen and so on and so forth, all the way up to building a transit system. It's pretty cool. The satisfaction is unrivaled. You are engaged. Obviously, anybody can zone out, but with the responsibilities that you have and the work that's there, it's complex, it's dynamic. I was never, ever bored. I used to say to my wife, if you see the cons, excuse me 1 second, let me take a drink. I would say for the last 15 years of my life, I averaged between 60 and 70 hours a week. There were 2 back-to-back weeks where I worked 95 hours. So the work-life balance can be a challenge. There's a number of engineers that are much better at it than I was, but the flip side was, and what I'd say to my new employees or my new hires, I'd say, guys, my day flies by. I get here at like 7:30 in the morning, and I look at the clock and it's already 7:30 in the evening. It's just shocking to me how fast the day goes by, because you're never bored. Job security, you're probably not going to find that. And there's a slide later on that shows you some of that. Engineers are always in demand. Advancement, both. I don't know if you guys might have interest in going up the management ladder. There's tons of opportunities, both on the technical side and on the management side. Diversity, like I said, culturally, you're never going to find a better, I think, type of job opportunity than engineering if you want to be exposed to folks from all over the world. And obviously travel opportunities. I've been everywhere. I've been to Asia, I've been to Europe, I've been to South America, I've been Australia. I mean, I've been everywhere, and it's been pretty cool. And then the pay, obviously the pay is about as high as you're going to get within most fields. Cons, like I said, it's a serious work-life balance at times. And you will struggle with that if you go down that road. At least most people do. And then it can be very stressful because there's always tight timelines and budgets to be met. So moving on, I thought I'd jot down some things that I thought might be beneficial for you guys if you are seriously interested in headed down an engineering path. So, you're going to want to take some serious math and sciences. There's no shock about that. Calculus, physics, so on and so forth. Join different clubs, physics clubs, engineering clubs, so on and so forth. If you get a chance, try and do an internship. That also is very beneficial for you. A lot of places, if you do an internship, they may help offset some of your costs again. And Jack, I saw your expression change when I talked about getting my my education paid for by Westinghouse Nuclear. There are opportunities out there. I would highly encourage you to explore that. What companies are noted for that in your area, and try to extend a hand out as soon as possible. I mean, get in contact with their HR department as soon as you can. Say, look, explain what you're doing, what you're trying to get to, and you'd like, if there's a company like I heard you, Jack, say that your dad works for Wabtec. Try and get an internship there. Try and get time there, because any of that stuff is going to be beneficial for you, both in terms of being accepted to a college as well as when you finally go to get a job. And then, enter competitions, and then build your English skills as well. Are we doing all right with time, Ty? Oh, I can't hear you, Ty.
I think you might be on mute. Sty,
you
are you on mute?
I am on mute. Yeah,
There you go.
it's 44 after right now, so I don't know. Zoom can kick us off at any time.
All right. Well, if you guys, I can finish through. I mean, there's not that many more slides, or you can look at them on your own. Whatever you prefer. I'm fine with that.
Whatever best suits what you guys have planned, I'm all right with.
Nate, you're all right to keep going?
Yeah, we can keep going.
All right, let's keep going then. All right. Understanding that you're both headed towards being an engineer, there's way that you can augment your bachelor's, if you will. One of the things that folks that are really committed to engineering is they take what's called engineering and training. There's actually a test that you have to take that you have to apply for. You take the test, you have to study for it. I think most people believe while you're either at the tail end of your college or shortly thereafter is where you want to take that test. And that actually does nothing in terms of how do I want to put this? It's not like a particular thing that is going to increase your salary or anything. All it's going to do is sort of show your commitment to the engineering field to your prospective employer. And it will also prepare you for if you ever want to be a professional engineer. Do you both know what a professional engineer is?
No.
A professional
really.
engineer, basically they're ones that can sign off on plans, drawings, designs, whatever it might be. And they
So-
are legally bound. And that is something that will significantly increase your salary level. It's not easy to do. I think most people spend 3 to 6 months after they graduate studying for that. You actually cannot get a professional engineering license until you've completed a certain number of years working under a professional engineer. I believe you can take the test. I never did either of those things, by the way. So I don't know that it necessarily limits you, but the professional engineer absolutely opens up doors that I could have never pursued, if that's clear.
Mhm.
There's an engineering master's degree, which you choose a very, very specific field. And it's not like you just choose nuclear engineering. You're going to choose a specific aspect of nuclear engineering to focus on, or civil engineering or whatever it might be. And it's usually a year to 2 extra that you've got to take to get your master's. And that will seriously open some doors as well as another side of things, which most of the folks that I hired in my bid management director role at Bombardier were both engineering bachelors, possibly a master's, as well as an MBA. So you can imagine how much money they spent on school. But then most of the people that work for me, I can tell you this, were making 90,000 to like 110,000, something like that. So a decent amount of money. So a master's of business administration, an MBA, as they say, really can open some doors if you don't necessarily want to spend all your time on the true engineering side. And that's, wait, so this one. I didn't show you this slide, did I? Did I skip over this?
It'd show us that slide.
Yeah, but don't know if you talked about it too.
I don't know what happened. I must have skipped over it or something. There you go. This one to me is important because it just shows you how much companies are in need of these types of engineers. And, you know, you see some of the other things and they're not quite as in demand. So very, very worth